Let's take a look at a demonstration problem involving free fall motion. A ball is thrown up vertically and is at a height of 12 meters above its release point after a time of 3.6 seconds. Part A. With what speed was it initially released? Part B. When it is at this height, is it going up or down? If we assume that air resistance is negligible, then after the ball leaves the hand and the hand force is no longer acting upon the ball, the only force acting on the ball is the gravitational force. And we know that this is free fall motion. We also know that free fall motion is a special case of uniformly accelerated motion. And we know for that we require three things for problem solving. We have three things. The displacement after the ball leaves the hand is 12 meters. The magnitude of the acceleration of gravity is 9.80 meters per second, and the time is 3.6 seconds. The unknown for part A is what is the initial velocity, and for part B, what is the final velocity after the ball has traveled 3.6 seconds? We need to know the final velocity because we're asked if the ball is going up or down. We know that if velocity is positive, position is increasing and the ball would be going up. We know that if velocity is negative, then the position of the ball is decreasing and the ball would be going down. Therefore, when we're asked if the ball is going up or down, we're really being asked what is the SIGN of the final velocity at that moment. Pick the correct equation. We use the need 3, fourth is what, fifth not known approach. We're given three things. We know the displacement is 12 meters. Given that the magnitude of the acceleration of gravity is 9.8 meters per second. We also know the time is 3.6 seconds. What are we looking for? We're looking for the initial velocity. That's the fourth is what? The fifth not known equation, the equation that will work, is it must have the three things that you're given and the variable that you're solving for. You must use all three things that you're given. You must have the thing that you're solving for present in the equation. Otherwise, you can't solve for it with that equation. The correct equation is the final velocity not known equation. So we write that down. Displacement S is equal to initial velocity times the time minus 1/2 acceleration of gravity, g, times the time squared. We're now ready to solve. So we substitute into the equation. We substitute in 12 meters for the displacement S is equal to the unknown, the initial velocity v sub I, times the time, 3.6 seconds, minus 1/2 the acceleration of gravity g, or minus 1/2, 9.8 meters per second, times the time squared, or 3.6 seconds squared. Algebraically rearranged for the initial velocity. And we get 12 meters plus 4.9 meters per second times 3.6 squared, second squared divided by 3.6 seconds. This gives us 20.97 rounded to 21.0 meters per second to three significant figures, the initial velocity that the ball left the hand with. Part B, the ball is at this height or at 3.6 seconds. Is the ball moving up or down? To answer the question, we use the equation final velocity is initial velocity minus the acceleration of gravity g times the time. If the velocity is positive at that time, it means the ball was going up. If it's negative, it means the ball was going down. Final velocity at time, 3.6 seconds, is the initial velocity, 20.97 meters per second, minus 9.80 meters per second, times the time, 3.6 seconds. We can tell that this is about 10 times 3.6, or about 36, so we're subtracting roughly 36, 35, somewhere in there, from 20.97 meters per second, and so without evaluating this, we can tell that it's negative. This means that the ball was going down at 3.6 seconds. Now it's your turn to try some homework problems on this material.